Okay, we're picking up where we left off last time, where we went over the different metric measurements, seconds, mass, volume, temperature, amount of a substance, and then we went over the prefixes. Everything that's smaller than the base unit is pico, 1 trillionth, nano, 1 billionth, micro, 1 millionth, milli, 1 thousandth, centi, 1 hundredth, deci, 1/110 or 1/10. Then we have deca, which is 10 times bigger, hecto, 100 times bigger, kilo, 1,000 times bigger, mega, 1 million times bigger, and then giga, 1 billion times bigger. What I'd like to cover right now is temperature. In this class, you guys will be dealing with a lot of different temperature equations, okay? And there's 3 different ones that we use here. And yesterday, do you remember how many countries still use the imperial system? 3. 3 out of 195 countries. I think there's 5 countries that still use Fahrenheit. Let's see. Hey, Siri, how many countries still use Fahrenheit?
Here's what I found from worldatlas.com. Today, countries that use the Fahrenheit include the Bahamas, Palau, Belize, the Cayman Islands, the Federated States of Micronesia, the Marshall.
I got it. 7 countries out of 195 still use Fahrenheit. And I saw a poster, and it made so much sense to me. So I want to share this with you. Fahrenheit was created by a German scientist. Why do we have Fahrenheit? Why do we have Celsius? Why do we have Kelvin? I've always wondered that. Here's why. Here's why they are. Fahrenheit is how humans feel. When I say it's in the 70s, you guys know how that feels. When I say things are in the 90s, you know how that feels. When I say it's 30s, ooh, I know how that feels. Celsius. What is Celsius based on? There's 2 really important numbers in Celsius, 0 and 100. The boiling and freezing point of water. This is how water feels. And I'll be impressed if you can tell me this one. Kelvin. You know, Varun?
0 is like absolute 0.
0 is absolute 0. There's no such thing as negative Kelvin. 0 is the coldest temperature theoretically ever. But if Fahrenheit is how humans feel, water is how Celsius is how water feels, what do you think has the feels for Kelvin? What do you think? It's okay to spitball. Go ahead.
I don't know.
You don't know? Anybody want to give it a shot? You're in chemistry. Varun? What's it made of? Closer. Come on. Huh? Smaller the molecules. Atoms. Don't be sitting there. I was going to say atoms. Go ahead and talk. How atoms feel. Now I'm going to teach you guys how to do these conversions. I want to teach you how to do the conversion between Fahrenheit and Celsius. It's actually pretty easy. When I was in Africa over the summer, we were in a lot of places with no Wi-Fi at all. I had my phone and I had a calculator. All of you had the calculator app. So I had to figure out, in Tanzania, they did Celsius. Our tour guide could easily tell me the temperature in Celsius. You know, I'm American. I understand Fahrenheit better. And so I could do this calculation. And I'll tell you to go back and forth. Okay, so Fahrenheit to Celsius. Here you go. What you do is if you want Celsius. Oh, wait. Yeah. If you want Celsius, you take the temperature in Fahrenheit, you multiply it by 1.8. And then you add 32. You do that, you get Fahrenheit. Or excuse me, you get Celsius. Sorry. So to put that to the test, do any of you know what the freezing point of water is in Fahrenheit? 32. Did I get this right? I think I got it flipped. I think I do have it flipped.
So make it more.
Yeah. Let's flip that. Cross that out. Sorry, I'm a little scrambled brain. I'll fix it. Fahrenheit to Celsius is going to be your temperature here. I got it. Okay. Fahrenheit is going to be Celsius minus 32 divided by 1.8. That's it. So what is the freezing point of water in Fahrenheit and Celsius? I'll write them down. We got Fahrenheit is 32. What is in Celsius? 0. Okay. So let's see if one number can get us the other. I want you to put in 0 minus 32 times 1.8. See what you get. Am I getting this wrong? Hold on. Okay. I'm messing up somewhere. It's all on YouTube. Great. Hold on. Let's start this over. I got this. Yeah. All right. Celsius to Fahrenheit. That's definitely it. That is definitely it. So if you do an example, you got a freezing point. I want you to convert 0 degrees Celsius to Fahrenheit. Go ahead and punch it in. You better get 32. I'll tell you right now. Try and do it in your calculator. You better get 32 degrees. You can probably do it in your head. 1.8 times 0 is what? Plus 32 is? Exactly. That's it. Okay, now let's flip it. Thirty-two minus 32 times 1.8. Yeah. There we go. So if I have 32 degrees, if you do an example, 32 degrees Fahrenheit, and once you convert that to Celsius, you can probably figure it out. What is 32 minus 32? What's 0 divided by 1.8? 0. There it is. Checks out. So there's the conversions. And I was having to do that a lot in Africa just to figure out and tell my travel buddies what the temperature was, because we're all born and raised in America. We're used to Fahrenheit. If I were to say it's 40 degrees outside, well, in Fahrenheit, that's cold. In Celsius, that's really hot. That's around 100 degrees. So we had to figure out how to understand what the temperatures were going to be for every day. But then I want you to now do Celsius to Kelvin. This is actually much easier. You need to memorize this. It's very easy. If you want Kelvin, you take whatever your temperature is in Celsius and you add 273. Technically, it's 273.15. I'm not going to be a big stickler on the 0.15 part. If you do 273 plus your temperature in Celsius, you've got Kelvin. So let's do an example. The human body is approximately 38 degrees Celsius. Can you tell me what that is in Kelvin? Varun, what'd you get?
Plus
38 plus 273.
311.
Correct. Now, you never say degrees Kelvin, guys. If I ever hear you say degrees Kelvin, here's my response. What? Don't you do degrees Fahrenheit, you do degrees Celsius, you don't say degrees Kelvin. So you just say 311 Kelvin. That's it. 311 Kelvin. If you want to go the opposite from Kelvin to Celsius, you do your temp Celsius equals your temperature in Kelvin minus 273. Pretty easy stuff. So using the equation you have, I want to give you an example. Varun mentioned something called absolute zero. The coldest temperature in the universe. You cannot get colder than 0 Kelvin. I want you to convert it to Celsius, and then I want you to convert it to Fahrenheit. And I want to see if you guys can tell me just how cold that is. That's not okay. That's 0 Kelvin. Can you tell me what that is in Celsius and tell me what that is in Fahrenheit? You got a question? You got a hand up? Alex, you had your hand up?
No.
Okay. Dane, what'd you get for Celsius? You don't have your calculator out with you. You need to have it out. He's got this one. Negative 273 Celsius is absolute zero. Anybody get Fahrenheit? What'd you get?
Negative 523.4.
We'll stick with a negative 523. Woo! That's chilly. So sure you did that right. $1.8 times 273 plus 32. Did anybody get something different than that? What'd you get? I got negative 459 too. I think you did something wrong.
Yeah.
It's in the 400s. I knew that. That number kind of.
Oh, I think I subtracted the 32 after.
Okay. Well, hey, live and learn. Mistakes are okay in this class. I just want you guys to learn from them. It's approximately negative 459 to be accurate. If you were exposed to absolute zero, your body would flash freeze, like flashed. Done. Yeah. There's not a limit to the heat. That's a fair question. Is there a limit to how hot things get? As far as we know, the answer is no. There is no limit. But as far as cold is, yes. Yeah. Because we put it in a lab. We've tried to see, we've asked those questions. Is there hottest? Is there coldest? And we've simulated temperatures in the lab. And in a lab, they've gotten really close to absolute zero. But they theoretically say in space, zero is where there's no star to provide heat. There's nothing. It's just zero energy source. That would be zero. That's what all Kelvin's based on. Okay, everybody. Let's move on to derived units. These are measurements that are measured with 2 units of measurement. This weekend, I have to go to Disney World, and Disney is about 65 miles away. I'm going to be driving there in my car. In America, how do we measure like our speed in a vehicle when we're going from point A to point B? Miles per hour. That is a derived unit. MI is miles. HR is hours. That is a derived unit. And we will have to stop there.